Okay. So we will be talking about environmental impacts and resource use, and specifically I would like to break it down into the following aspects. The first one is about why should we actually care? The second part is more about human impacts and why is our action having an impact on the environment. And then we go into environmental impacts specifically. We first talk about emissions and then about resource depletion, and then end with looking at the resource aspect in general. So I heard that this is for general public, so I try to make it more basic and less chemical and try to explain it as good as possible. And in order to get to know you a little bit better, and I know now that you all know how to use this guy here, it sounds a little bit like, wow, we should protect the environment because we should be good people and we should, we have this responsibility. But I do think environmental protection actually goes, at this point, beyond that. It's not about us wanting to have, back to the nature. It's really about what can the environment support us, or what are we currently supported with, and how is that, or how are we going to protect it in order to sustain human well-being on this planet. So I quickly want to bring up this concept over here, which is the ecosystem services. And we are looking into what is the environment actually doing for us. And if you look into this circle over here, actually at HKUST, often when the students are applying to our program and we ask them, why do you apply? They say something like, oh, I love the beauty of nature. Yeah, which is great. It's like what we call the cultural service. But the key essence about why we are teaching environmental protection is because we are very interested in these other services. So provisioning services is basically resources and what we get from the environment, but the environment does more. Supporting services over here is anything from photosynthesis, water circles, and the cycling of nutrients. And the most interesting part that I think is this one over here, is that when humans are interacting with the environment, we leave emissions, we do disturb the environment, and generally the environment has a pretty good capacity to deal with us. There's a lot of mechanisms in place what the environment is doing in order to deal with human disturbance, but if we are pushing it too far, as what we are doing in some cases with toxicity, in some cases with eutrophication, in some cases with climate change, we are hitting a point where we actually need to do environmental protection in order to sustain our current lifestyle, or hopefully also that of the future generations. Not picking up. Okay, so if you have questions along the line, feel free to anytime raise your hand. I know sometimes people are not that comfortable to talk before, in front of everybody. So you can scan this QR code and keep it open, and if later on there's something, I will check from time to time onto the Mentimeter. I was planning to have it open on one screen, but somehow that didn't work out, but I will check from time to time over there as well to address the questions that come in. But you're also happy to raise your hand, so I give you 5 more seconds to scan it in case you want to use that option. Okay. So the question is, when we talk about environmental impacts and when we talk about resource use, one aspect is what actually drives human impacts. And one concept that we use a lot at HKUST, or I see all of my colleagues teaching this concept again, is the following equation. Has any one of you heard of this one before? Yeah, some of you are nodding, some of you are shaking. Okay, so this is basically a very simplified concept that says the impact is based on the population, so how many people we are. That can be a few people in a certain city, or it can be the global population. It can also be just a part of the population who are doing a certain activity. So this becomes important in just a moment. And that is multiplied with what we call affluence. It's basically how much we are consuming. So if we look back in 2000, the year 2000, people consumed half of the amount of t-shirts or of textiles as what they did in 2015. And what we can see is that consumption patterns have been changing a lot, and accordingly, the impacts from this kind of factor has been going up. Now, the last aspect here is technology. So if you think about what we're trying to do, for example, with the energy efficiency label, to try to reduce emissions and put on the labels in order to indicate which of these refrigerators are actually more sustainable, then this is a technology aspect. Now, the thing here is that we want to manage the impacts in a way that they are acceptable to the environment. We cannot avoid impacts completely. And often people say like, oh, we should serve our environment, or we should be good to our environment. Well, to be frank, the best thing for our environment would be if we were not here, because all of our impacts or all of our actions have impact on the environment. But in order to manage them, we do need to manage these three different factors. So as we know, population is something that is still currently growing. And in most societies, the consumption is also something that is increasing. So in that case, we need to have really good technologies to come in order to counterbalance this, in order to reduce our total impacts, what it is that we want to do, in the long run, in order to protect, for example, the climate. So I have here one example, which is a French example for CO2 emissions from household cars in France. And I translated it for you into English. There are here the different factors that contribute to the total emission change. And I want you to have a quick look at this and think about which of these bars reflect the T, the A, and the P factor. And what is the overall conclusion that we actually get from this chart over here? So is this chart good news, bad news? So let's start on this side over here. Which kind of factor would you give to this first part here?
Technology.
T, very good. How about the second one? So the first one here is the CO2 content of fuels. How about the second one? Also technology, right? We are making the car more fuel efficient. So these two guys, this is good news. Both of the technology aspects are decreasing the emissions. Now, what happened in the meantime in France? What are the other two factors? So I would assign them in this way. So this one here is the consumption per person. That is the A factor and the P factor. And what we can see is that the amount that people have been driving and also the amount of people who started to drive their own car has been increasing, which has accordingly been increasing the total impacts. So what we can see over here is what we often call the rebound effect. Now, is this something that is also happening in Hong Kong? If we think about private vehicles in Hong Kong, and the government is pushing for a lot of initiatives in order to, for example, to switch the fuel from gasoline to LPG or electric vehicles and to improve the efficiencies of the car, do you think we would also have this type of effect happen in Hong Kong? Could be, right? People might be driving more. One efficient way to not let that happen could be regulations. So in Hong Kong, if you know, we only have around 10% lucky people here in Hong Kong who can have their own car. 90% of us don't. So the population part in Hong Kong is actually quite small, and the number of license plates that the government is giving out is not that big. So accordingly, this kind of rebound effect could probably be prevented if the French government would have set, some sort of regulation. So let me give you another Hong Kong example. So if we look into this aspect over here of energy consumption in Hong Kong, public housing and private housing, and in 2009, the MEELS has been implemented in order to have more or push for more energy efficient appliances here in Hong Kong. So the first thing that I want you to look into is refrigeration. Would you say the refrigeration was, the implementation of that scheme was successful for refrigeration? Yes, I see some people nodding. How do we know? Or what happened over here? So in this case here, the labeling scheme is addressing this part here, right? The T aspect in order to bring down the emissions per consumption. And in terms of refrigeration, that worked quite well. We can see that between 2009 and 2019, the energy consumption went went down almost half in both cases. Now let me show you the air conditioning data. And let me ask you one question. Do we also have the label on air conditioners? Yes, right? How is it possible that for air conditioning, we actually see an increase? And for refrigeration, we see a decrease. What's the difference between refrigeration? Anyone who has a refrigerator at home? Anyone who has 2 refrigerators at home? No, right? Our flats are normally too small. Anyone who is after the MEELS scheme has been implemented, running their refrigerator on the lowest possible temperature because you think it's so energy efficient? Maybe not, right? We are still running it on standard because this is something where people would not consume more than what they need. How about air conditioning? What might have happened here in this time while the MEELS has been in place?
Getting warmer.
It's getting warmer. So which factor would be affected in that case? What would people do? A, very good. So people might turn on the aircon more often, right? They may previously have turned it on for, let's say, 1 hour, 2 hours, 5 hours per day. Now they run it longer. Or they run it at a lower temperature. And that makes the consumption go up. Also, what might have happened is that some people, they didn't have air conditioning before, and then they bought it. So there might have been a shift there as well. So what we can see over here in terms of the impacts, if we are just trying to rely on technology improvement only in order to address environmental impact and ignoring the consumption factor, it becomes very difficult to manage how many resources and how many emissions we are actually creating. Yeah?
I just got a question on the slide. I just a little bit curious because for the air conditioning, it seems for the public housing is increasing, while for the private housing is decreasing.
This one here?
Yeah.
Yeah, here again, decreasing, right? Yeah.
Suppose for the private housing, maybe they are more, have more money spent on the air conditioning, but it seems just different right now.
So yeah, it's a good question why over here there was not too much change anymore. So we can think about different scenarios. I'm not so sure what people did between 2014 and 2019 that made the consumption drop slightly again. It might be that it was less hot. It might be that people already were quite saturated or just kept the same standard. Good observation. Okay, very last example over here, car sharing. Is car sharing sustainable? And this is something that I actually discuss always in my sustainability class. And if you have time after this workshop, I highly recommend you this paper here, which is called There's No Such Thing as a Green Product, because I think it is something very eye-opening. I think we will be sharing these slides with you so you can follow up on that. So if I would ask you, if we implement car sharing in Hong Kong, is it more sustainable? Car sharing, that we have like a company where you can rent the car, drive the car, return the car. Similar to what we had with the bikes, right? We could have bike sharing, bike rental. Would that be something sustainable? Because it sounds sustainable, right? Sharing economy is one of the sustainable approaches. maybe we do a quick vote. Who would say, yeah, I think actually it's quite sustainable. I think this is a sustainable business model. Okay, let's do the counter check. Who would say the opposite? I'm doubtful that it is sustainable. Ah, great. Anyone who says like, nah, undecided? Like anyone who says, depends? Yes, great. I like that. Okay, let's quickly ask somebody who raised their hand for you think it's not sustainable. What might be factors why it may not be sustainable in Hong Kong?
Well, I think the consumption would also grow. Because now, as you mentioned, that people mostly use public transportation here. But in this case, more people would go for sharing the cars, so that would grow the consumption.
Excellent. So for this case here, the question is, the consumers who are renting the car, what did they do before this option was available? Did they have their own car? They gave up their own car, and then they from time to time rent, or they don't buy a new one once the old car is broken, and then from time to time they rent this car in order to have a vehicle available, then it's probably more sustainable, right? Because their other car might be old, might be not as fuel efficient, they may not use it as often. But the majority of people here in Hong Kong, they don't have a car. So if this service becomes available, probably a lot of people would start using this kind of option. So in this case over here, it might actually be in the Hong Kong case that even though it sounds like a sustainable model, it may not be. Also, it might be that people who had a car before, let's say, oh, maybe I also call on you. Why would you say depends? Depends on what? Do you mind explaining a bit?
I actually don't have the answer in my mind, but I think sometimes when we have this kind of scenario, I think the people behavior can't quite really think immediately. It really depends on the market. I think there's a lot of factors counting when we have this kind of actions.
Yeah,
so
very good.
In my mind.
Yeah, but it's a very good answer because it's not just the technology or the product itself that is sustainable. Any product can be unsustainable if it's not used the right way. Let's assume this bottle over here is actually quite sustainable, right? If I reuse it many times, then I can avoid a lot of single-use plastic or so. But if I buy this bottle and then in the end, I keep forgetting it at home and I don't use it, then it's better if I wouldn't buy that product in the first place. And actually, we have been running a survey on campus to ask the students, how many of these kind of reusable containers do you have? And most people have like 2, 3, some even 6, because they were given away as takeaway so often. So in that case, sometimes it might be that people who used to be rejecting this type of business model, like not going for a private vehicle, not buying a certain product, and once you advertise to them a more sustainable option, they may jump on the wagon and actually consume it. So there are different kind of factors, and I wanted to raise this because often people claim something is sustainable without giving a lot of evidence, whether that is always the case. I don't want to mention that it's good to measure the life cycle impacts behind, but in general, it is something to, good to think through if you're from the corporate sector in terms of what would actually be the sustainability aspect of it. So when it comes to products or to environmental impacts in general, one thing that I think is very important to remember is that every product does need to go through different types of stages. Here's a life cycle of a washing detergent. And you can see that washing detergent, it does need certain raw materials, for example, palm oil, regular fossil fuels, different other kind of ingredients that you wanted to have inside that detergent, like other natural ingredients. Then it goes through the processing, further production, packaging, retail use, end of life for the sewage, and also for the packaging. Now, generally, impacts are happening everywhere along this life cycle. And the reason why I bring this up is when we talk about resource use, when we talk about emissions here in Hong Kong, what kind of resource use and emissions happen in Hong Kong out of this life cycle? Washing detergent. Which of this part actually happens in Hong Kong? End of life, definitely, right? Everyone is talking about plastic containers on landfill. So this, for sure, we do have. This part here as well, right? Sewage treatment. Use, definitely as well. Retail, yes. Then how about these guys here? Some may happen here in Hong Kong. Often, a lot of the things that we use on a daily basis are actually imported to Hong Kong. So when we are talking about resource use, when we are talking about emissions, what is it that we should be paying attention to? Right? So when it comes to carbon emissions, let me quickly see. I think I have it on one of the following slides. When it comes to the carbon emissions, there's very clear guidelines, right, on scope 1, 2, 3. But when it comes to other environmental impacts, what are we as people who are in Hong Kong, who are doing business in Hong Kong, what are we actually responsible for? And why is it probably important to understand the life cycle of the products, the life cycle of the systems that we are working on in order to make better decisions? So life cycle assessment is a tool that helps to systematically analyze what are the resources that go into each of these stages of manufacturing, of extracting raw materials, and what are the emissions that actually come out from there. So why should we care about this? As I just mentioned, a lot of things that we consume here in Hong Kong are actually not made here. So has any one of you ever seen this difference between consumption-based and production-based carbon? When the Hong Kong government is disclosing carbon per capita, which one are we disclosing? Production-based, right? This one over here. And we are all very lucky that CLP has been switching from coal to gas, because that, without us doing anything, bringing the emission factor down. So the production-based emissions per capita is basically whatever happens within the Hong Kong territory. And the consumption-based ones are what we are actually consuming in Hong Kong. So it is calculated by looking at the production, or the production-based one, deducting what is exported and adding on what is imported. So all the items that we are using, the carbon emissions that they are responsible for along their life cycle is added on. So what can we see in terms of the difference between the numbers? Let me put it a bit bluntly. Hong Kong is a pretty big free rider, right? Because most of the resources are used somewhere else. Most of the emissions happen somewhere else. May not be true for every single product, but generally it is. So there's quite a bit of discussion about how much responsibility do we actually have on these kind of emissions. Does any one of you work on science-based targets? Oh, okay, a bit. Anyone who has heard of this term? Okay, let me briefly go over it. So when it comes to greenhouse gas emissions, there are different types of scopes to it. And people normally say, like, whenever you directly emit carbon, for example, you drive your company vehicle, or what are other emission sources, or you do some cooking in the kitchen, or you have something, using some gas. Let's do it on a personal level, consumer basis. So scope 1 is anything where you directly release emissions. So you do some barbecue, you do some cooking with gas, you drive around with a vehicle. These would be direct emissions, and all of these are scope 1. Scope 2 is the electricity that you use. So you're not sitting on your laptop and the CO2 is coming out, right? But the electricity that is used, the CO2 is produced at CLP or Hong Kong Electric, right, within Hong Kong. So that is what we call scope 2. That is coming from the electricity that we use. Now, do you know in Hong Kong, if you're a company, which scope do you need to report? Scope 1 and 2, right? Yes. So this is a big headache of many people at the moment. Scope 3. What is Scope 3? So Scope 3 is any materials that you're using for your manufacturing or for your processes that were not, made in your facilities. So for example, if we use the washing detergent example, then the emissions that come from farming the, let's say, palm oil in Indonesia, the emissions on the field, all of that would be your Scope 3. It doesn't happen in your manufacturing site here in Hong Kong. So Scope 3 is something that currently it is not mandated in Hong Kong to be disclosed under ESG, but there is more and more steps towards reporting these things. Now, Scope 3 includes something else, that is what happens downstream. So if I'm selling this bottle to you, then, or let's say I'm the manufacturer of this bottle, then probably I use electricity. That's my Scope 2. I may also use, some vehicles to deliver it. That might be my Scope 1. Might be my Scope 1. And then all the raw materials come from, let's say, mainland China. That would be my Scope 3. So when I pass it on to you, all of the emissions that I was responsible for are your Scope 3 emissions. Okay, so it's a kind of system that it passes on. But whenever you're throwing this away, or if you're using this bottle in a way that it consumes energy, like, I don't know, maybe you heat up the bottle in order when you fill the water in so that the water keeps warm or something like that, then you would also use electricity while you're using it. So that would be your Scope 2 or Scope 1, depending on it. And it is my Scope 3 because it's a downstream. So let me go back to the life cycle because I think it is easier to understand. So Scope 3 is generally all the raw materials, ingredients, aspects that you're not making in your own manufacturing sites, but making them also requires inputs and causes emissions. So in Hong Kong, when we are getting the laundry detergent over here, then most of these things are our Scope 3, and things that happen over here would be our Scope 1 or 2. So in terms of disclosure, this is something important because Scope 1 and 2 is pretty easy to measure. If I drive my own car, if I know roughly what is the emission factor, then I can calculate how much fuel did I use and how much emissions come out. If I use electricity, CLP Hong Kong Electric are disclosing the emission factor to me, and I can calculate that. When it comes to Scope 3, there are suddenly a lot of suppliers, a lot of different materials. They may come from all over the world, and it suddenly becomes really difficult to understand what did they do in order to make this product, in order to measure what are actually the emissions that come from there. So that is why I see some people take a picture, and then I leave it on for a moment. So that is why when we talk about resource use, when we talk about emissions, especially here in Hong Kong, the question is about how many of these resources and how many of these emissions should we care. So if you're a company, like for example Walmart, and you want to subscribe to these science-based targets, then you have a quite big problem. Because most of your emissions may not be the electricity from the lighting and the cooling from the fridge, but most of the emissions that you're responsible for are actually coming from the stuff that you sell. And there's a rule that if that is the case, if it represents more than 40%, you have to also account for Scope 3. So I think it is something that can be quite applicable for people here in Hong Kong as they are moving towards this direction of disclosure. And it is quite difficult to measure these kind of emissions. Life cycle assessment can, to some extent, help with that, but it is, in general, difficult. But we do see that, for example, and no advertisement for Walmart, I actually never went there, but what they, for example, do is they work with their suppliers to help them measure their emissions. Why? Because many of their suppliers are small companies, farmers, they may come from developing countries. They may not have the capacity to do these kind of measurements. So going back to the question, how much of this should be our problem? How many of the emissions and resources are we responsible for? Currently, only what happens within Hong Kong is your problem in terms of disclosure and in terms of having to measure it. But there's more and more push to say, like, companies should also look into other emissions that they are responsible for. If you have a very unsustainable supplier, then why are you not doing something about it, right? Of course, we could say, like, oh, we switch to a more sustainable supplier. But what if all your suppliers are so small companies that they don't have the capacity to make their emissions less? So this discussion in terms of how can we actually reduce our emissions holistically and not just with what happens in the Hong Kong territory, I think is an important question to think about, because in the end it determines basically how effective we will be in reducing our emissions altogether. There's something that I often tell the students, or in general people, is that the government doesn't, the environment doesn't care about how good we are in marketing our stuff, in running our campaigns. The environment will react exactly to what we do to her, or him, or however you want to it. So if we are effective in reducing the emissions and reducing our impacts, not just improving our technology, but also thinking about other factors, such as consumer behavior, such as the emissions that don't happen within my circle of my company, but also with my suppliers. Only if we understand these kind of connections, we will be more, able to holistically reduce emissions and reduce our impacts on the environment. Okay, up to here, are there any questions? I quickly check if there's anything on. Okay, so when we talk about the environment, normally we talk about an interaction between air, soil, rocks, water, and us, or plants, or animals. So when it comes, for example, to the atmosphere and water, they are connected through the hydrological cycle, right? The water is evaporating, it's raining somewhere else, so it forms clouds, rains somewhere else down. The pedosphere and the rocks are actually connected as well, because originally the soil is only forming, and I'm not sure whether you're familiar with that process. If you have some plants and they're decomposing the soil, then the rocks gradually, it will become soil. So it's plant material that decomposes. So we do actually have, between all these kind of compartments, interactions. So even if we solve one of the compartment's problems, they normally are interlinked. So if we release no more toxins in the air, probably there may still be evaporation from the water and things like that. So this is, I think, very important, that when we talk about the environment, it's a system that is interconnected. And whatever we release into the environment, or whatever we take out from there, can come from different areas, but this is like the key aspect in terms of what we're talking today. So what I would like to ask you before we go now into the break is which of these environmental impacts are you familiar with? Because I will only go over those that you're less familiar with, and I won't repeat too much on those that you already know. So let me switch back to Mentimeter. A lot of Mentimetering today. Okay, so you can use the sliders depending on whether you think like, what? Never heard of this? Or, well, I could actually explain this to someone else, so I'm quite familiar with this concept. Great, I will also be sharing the PPT with you. I just hide all the slides about climate change because I would say this is pretty much an expert level that we have for most people here, so I won't go into that one anymore. And I will focus on most of the other ones. Some of them, particulate matter seems also be, this guy here also quite strong. Okay, let's go over them. And then for some of them, I will keep it a bit shorter. So one of you asked me, what is my view on carbon markets? That is a very difficult question. I think I probably only have very basic knowledge about environmental economics and carbon markets. And oh, I think, Karina, when you introduced me, I actually don't teach environmental economics. But I have heard about carbon markets. I think similar to many environmental initiatives or assessments, I find that it's difficult if things seem to be not aligned between different countries, or if different countries use different standards to determine what is green finance, what is a green bond, how to do the LCA correctly. And I think something similar I see with the carbon markets. As long as they are, in a certain region only, in a global world, it seems to be there needs to be more alignment. But that is my very basic view. So happy to discuss more with the person who posted that question. But I only have a very basic knowledge on that. Okay, so let's jump into some of the environmental aspects. We will start with soil and water pollution. And yeah, let's go into that. So let's assume we are putting a whole load of different kinds of nice chemicals onto the soil. What will happen? Let's say a good mixture of pesticides and fertilizers and some industrial chemicals. We plug it all into the soil. Let's pretend these are the chemicals. What will happen to them? Yeah?
It will accumulate in the plants and then go into the ecosystem.
Excellent. That is one of the things that it can do. I also have that as the first thing on my list. Some plants can take up certain chemicals. So here in green, certain plants can take up chemicals. For example, certain cabbage plants, they are very good at taking up specific heavy metals. So if you love to eat cabbage, probably also pak choi, these kind of things, they are a little tricky because they can take up certain chemicals into the plant and store it there. So this is one thing. Actually, it can also be a benefit if you have a highly contaminated ground. One of the ways to clean the soil is to plant many different plants that can take up chemicals from the soil. And once they're grown, you harvest them and dump them on the landfill or burn them in order to get the chemicals sucked out of the soil. So it's one of the soil remediation methods. What else can happen to these chemicals in the ground?
I think the term is called salinification.
What would that be?
Causing a lot of salt buildup in the soil, and then the soil later is not able to use for vegetation and stuff.
Excellent. So actually what happens with salt is that it dissolves in water. If the water is gone, the salt will stay behind and attach to some of the particles that are in the soil. So if you're a salt, you likely attach to the minerals in the soil. If you are a organic chemical, like a fertilizer or so, you're probably more attached to the organic matter, like the plant materials or the decomposed, brown soil. Now, that is something that you may or you may not remember. One thing that I remember from my soil remediation class that I had when I was a student, we went to one of the locations that used to be the Eastern German chemical manufacturing site. And they were just literally flushing down chemicals down the drain into the environment. And when you went there and walked around in the nature there, and you picked up a bit of the soil sediment and smell, then it has like a very nice chlorine smell. And it stayed there for decades. Why? Because some of these guys here, especially if they attach to the organic matter, they are very hard to dissolve in water. So even if the rain comes, it may stick on there. So that is one of the things that can happen. Another thing, or what else could happen? If you put it on the soil, what else could happen to the remaining chemicals? Another thing is that they may leach into the ground or into the groundwater and then into the rivers and so on. This is something that happens a lot with fertilizers. So generally, the reason why farmers apply a lot more fertilizer to the field than the plant can take up is that plants are very slow in taking up fertilizer. So before the plant is taking up the fertilizer, a lot of it will already be washed out, or, and I think that is something that comes on the next slide, be broken down by microorganisms. So the plant is simply too slow to take up everything. That's why we heavily over-fertilize. For some crops, it's even like 40% more, or large amounts of fertilizer that then get just washed out and causing problems there. We will talk about eutrophication in just a moment. And then other chemicals, and all of this depends on what is the chemical characteristic or the physico-chemical characteristic of that chemical that we release there. So different chemicals can do different things in the environment. They don't all do the same thing. So not all of them may end up in the groundwater, only if they are very easy to dissolve in water, for example. So what happens once they are distributed in the soil here? Once you attach something to the soil and it's no longer in the soil water, they are easy targets for microorganisms. So microorganisms in the ground, they have the capability to break down certain chemicals. And what would happen to these chemicals? Different things can happen. Either the way you break them down makes them more water soluble, and then they can be washed out, or it makes them more easy to be attacked by other microorganisms and be broken down into water, CO2, and some other chemicals. And one more thing that is here important, does anybody know why agriculture, or this kind of farming, contributes to climate change? I think I just had it here in the animation. Look one more time. Oops, that was wrong. Yeah, CO2 is one of them. So actually, many of the microorganisms in the ground, they like nitrogen. And nitrogen is normally very rare to get. As soon as you apply fertilizer to the ground, microorganisms are very happy. And they will start, digesting these fertilizers. And one of the products that come out is N2O, nitrous oxide, and that is a very strong greenhouse gas. It's also an ozone-depleting gas. We come to that in just a moment. So the more fertilizer we put on the ground, the more active these microorganisms become, and the more greenhouse gases they will be releasing. Okay, so this is a natural process, happens in all of the soils. But normally, they don't get that much fertilizer. They don't get that much nutrients. It's a little bit like birthday for them, birthday and Christmas together. They get a lot of food for them, and that's why they become so productive. So what can happen in the soil is some of the chemicals get broken down, and some of them, they just accumulate. I think somebody of you has also just been mentioning that. So it could be remaining in the soil for many, many years if it is a very stable, non-reactive chemical that easily attaches to organic matter. Now, what of course can also happen, and here it's just a rabbit, but if you like to eat, then this is something that can also happen to you. The plants, of course, could then bring the chemicals into the human body or into the other organisms. Okay, so this is related to eutrophication and toxicity, which were just on the list. And I quickly want to go into a few more details. I will skip this one here. So if you want to watch the video, you can do that on your own, and I will just briefly go over that. So eutrophication, as I just mentioned, is basically an over-fertilization of water bodies. So in Hong Kong, we also sometimes see algae grow. Most of that is natural, though. I think it can be related, but doesn't have to be eutrophication. But in general, how we identify eutrophication is that we can see some green algae covering water surfaces. So what happens is that the fertilizer is washed out into the ground, gets transported into the river or into the lakes. And over there, there's a lot of algae who also use this fertilizer as, nutrients. And they can grow much more than they normally did. And what happens after that is, number one, they will be blooming and covering the surface. And if they do that, the oxygen has a very hard time to get into the water, and also the sunlight has a hard time to get into the water. So everything that lives under that blanket of algae has a hard time to get access to sunlight and to oxygen. And that is why we see fish dying, we see different kind of other animals or plants dying in these kind of zones. Another thing is that it can also happen in terrestrial systems. So if we add fertilizer for our plants, of course, any kind of weeds or other plants may also get very happy and grow, a lot more. So there are different kind of implications of that. So I think here this one is a picture where you can see a lot of fish mixed into the trash. Probably that is a result of eutrophication. Any questions about that? Otherwise, we move on to one of my favorite topics. When I was in university, I studied ecotoxicity as one of my major subjects. And our professor was always trying to tease us in terms of what we should do in daily life and what we should not do in daily life in order to reduce our toxic intake. Okay, so anyway, when it comes to toxicity, and I think I will quickly go first to this slide over here. Many people think that if something is toxic, it causes cancer and makes you die. But toxic does not just mean cancer and dying. Toxic is anything that causes harm to the human body. And also there are normally different kind of chemicals that have different kind of target organs. So for example, if you're using some old paint that contains cadmium, then that kind of cadmium will go into your kidney. If you're one of the poor kids, which we are not, if there's a poor kid in a location of gold mining and they're using mercury, then the mercury will attack their nervous system and their brain. So different kind of toxins, they have different kind of target organs that they will move into once you get them into your body. They can make you sick. Ultimately, they can cause cancer. They can also make you die, but it doesn't have to be. It could also be that you can just get sick from it. So there's two ways of how you can get sick. One is if you have a very high dose. So for example, when I moved into a new flat here in Hong Kong, the flat had a lot of mold on the wall. So what I thought is like, okay, I just wash it off, all off on one day, and then we move the next day. But while I was washing it off, I inhaled so much mold that I got sick the next day. I got really sick with fever because I inhaled too much of the mold, which caused a toxic reaction in my body. It didn't make me die, but it made me sick for 2 days because I had a too high acute dose of this. Chronic toxicity is something that happens if you take small amounts of chemicals over a longer period of time. So for example, with food, often the concentration of different kind of chemicals or toxins in food is not super high. But if we repeat eating the same food, so if you are super into cabbage and you repeat eating cabbage every day, like me, I eat a lot of cabbage, then your chance that you accumulate different kind of heavy metals in your body is much higher. And over time, it may come to effects that it is causing a toxic effect. And this is something very tricky because most of the time, we have no idea where that comes from. So I can tell you, I got sick because of mold, because I had a very high dose of it, and it was quite obvious. Chronic toxicity is very difficult to detect because it happens in our daily life alongside with many other things. It may also be that different kind of chemicals react together in our body and have a party and make us sick. So it's something that chronic toxicity is something that develops over time and can accumulate. And one thing for anyone of, especially fish lovers, there are also a lot of chemicals that accumulate in fish, and we call this bioaccumulation, if the toxins are accumulating in certain organs, for example, in your body. And if that happens, for example, in the small fish, and then that gets eaten by the bigger fish, and the bigger fish eats a small fish every day, then he accumulates even more of that kind of chemical. And if you're then the one who is eventually getting the fish and eating it, it can be that you have a quite large amount of this kind of chemical in your body. And we call that biomagnification. So it magnifies the higher it goes up this trophic level. So in terms of fish, unfortunately, it's something that it's very difficult to control, especially in the sea, how much toxins these kind of fish or shellfish are exposed to. And they attract different kind of toxins into their body through their food. Okay, let me see. Anything that I missed? So I put up here some of flow charts in case you were interested in that. That is from my life cycle assessment book, and I thought it's a nice split. One more thing that I want to mention here is that in terms of toxicity, we normally distinguish between eco-toxicity and human toxicity, because something can be toxic to human, but it doesn't have to be toxic to animals or plants or the other way around. If you have, for example, a dog, if you give your dog chocolate, very likely the dog wouldn't survive. Or if you give the dog raisins, but for us it's totally no problem to eat chocolate, right? So different species have different reaction to different kind of chemicals, and something can be toxic to one, but not the other organism. Okay, moving on. Oh yeah, economic consequences. I put this reminder over here. One thing with toxicity, especially if you, in the case of Germany, that location where they dump a lot of chemicals into the water or into the ground, it's a huge issue that if companies release toxic chemicals and then they go bankrupt, it's normally a big problem for the community. Also, if industrial plants release water and the surrounding area has a lot of farming. We do have in China quite a number of what people call cancer villages, where industries have been releasing a lot of effluents that had toxic chemicals, but people, because they were simply too poor to eat food from somewhere else, had to rely on what they were growing on their own fields. And that is something in terms of toxicity that, the responsibility is always a question. Because normally after the company disappears or moves to another country, the impacts of the toxicity has to be borne by the community or the government who uses tax money in order to clean up the space or pay for the health cost. Okay, very quickly, where do normally the chemicals come from that cause eutrophication and toxicity? So phosphorus and nitrogen are key fertilizers. They also come from sewage treatment, anything with human feces or animal feces. They normally have a high concentration of these guys over here. And in terms of toxicity, there are thousands of chemicals. So some chemicals, they are very similar, but one is toxic, one is not. So there is a list of super toxic chemicals, but it goes along the range. Normally, sectors that are very tricky in terms of chemicals or toxic chemicals are mining, recycling industries, textile industries, leather industries. I put up here a list, but there are different kind of chemicals, especially chemical dyes, what you use for the leather to remove the skin. These kind of chemicals are very, very strong and accordingly cause severe problems, can cause severe problems to the people who wear the clothes, for example, but most of the time it's the workers at the plant who will be affected by that. Okay, so very briefly to wrap this up, ecosystems. Normally what they do with the emissions that we release into them is they would be getting distributed. They go into the air, they go into the plants, they go into the water. So the environment normally distributes the emissions that we release into it. And also they would be breaking down either by the sunlight, by microorganisms, and things like that. These are natural processes. So the environment actually has a really high capability to deal with all the crap that we release into it. But under different conditions, such as really high concentrations, very stable or non-reacting chemicals that accumulate, chemicals that can very quickly get into the body and accumulate inside the body. So these are conditions when toxic chemicals can become a big problem, even in a small concentration. If it's easy to get into our body because if it's, for example, released near our food or on a farming land, then it can be very tricky. Okay, let's move on to air pollution. Or any more questions about toxicity? No, okay. Quick, air pollution. So let's do the same exercise again. I release a nice cocktail of air pollutants into the air. What will happen?
Dispersion.
Very good. Why?
Pressure difference, concentration difference.
Okay, very good. So diffusion is one thing that is normally a little bit slower. What else can help us to distribute the chemicals and make them have a lower concentration?
Buoyancy.
Sorry?
Buoyancy.
What is that?
That means that.
Oh, yeah, convection. Yep, very good. And also wind, right? So there are different kinds of ways of how we can disperse the chemicals into the air. If you have ever wondered why, or have you ever wondered why, if there's a typhoon coming, the air quality is so bad? Anyone ever noticed? There's actually more people getting sick and dying in Hong Kong because the air quality is getting bad right before the typhoon. And the reason is that these guys here become very weak. And then for a few days, we are sitting in our own mess. Our emissions keep accumulating on top of the city and are not, getting dispersed as they normally get. So not all the bad stuff is coming from Guangdong. We also do quite a number of things here in Hong Kong. So in terms of what happens after, really depends on whether these gases are stable or whether they are reactive. So if they are reactive, they do all kinds of fancy reactions in the atmosphere. So for example, what they can do is like they get hit by the sunlight, they break down, then they react with different other chemicals. They may react with particles. There are different kinds of things what these chemicals can do, and they normally mix and match. And also what happens is that while they are reacting in the atmosphere, they normally become more water soluble. So they are easier to dissolve in water and less easy to fly around. That's because of the sunlight and because of the conditions in the atmosphere. And what happens afterwards, can you guess? Here, if you look at this one here, ding, ding, they will be removed. So reactive gases normally don't stay in the atmosphere for super long. They react, they cause different kind of phenomena like forming particles, forming smog, forming ozone, forming acid rain, and then they are removed with the rain or a few different other mechanisms. So normally they are short-lived in the atmosphere, so they don't stay forever. Now, how about stable gases? Stable gases, as it says, they stick around. They just don't react. They are quite immune to the sunlight in the atmosphere. So what they're doing is that they can distribute over really long distances. So over here, we can see global warming and ozone depletion. And I only will look into ozone depletion now, because that was something that some of you mentioned you don't know it as well yet. So ozone in the upper layer of the atmosphere is actually something good for us, right? You may have heard of the ozone hole, and that is problematic. So why is there ozone in the atmosphere? We have a lot of oxygen in the atmosphere. And when the sunlight comes in, it breaks down the oxygen and reacts to form ozone. And that's why very high up in the atmosphere, we have a lot of ozone because of this reaction. Now you may wonder, why does it happen very high up in the atmosphere? because the sunlight, the UV light, is super strong there. It hits the Earth, and when it hits the oxygen here and forms the ozone, it basically gets filtered out. So the sunlight is needed in order to trigger this reaction, and like that, it's kind of removed from what is coming down to Earth. So UVC and UVB are involved in this reaction. So there are different kind of chemicals, like nitrous oxide, what we just mentioned from the bacteria, that are inhibiting some of these reactions by disturbing the reaction flow. Also, chlorine containing gases can do something similar. So there was one question, a very good one, asking why is the ozone hole over Australia? Why is it not in the location where the emission happens? Very good question. The answer is because it's a very stable gas, and it will distribute very far distances. So the distribution of the chemical will happen first, and then it moves further upwards. And then when it gets to the very top, it will start reacting with the ozone up there. Now the question is, why is there a hole over the Antarctic and Australia? That's because there's a certain turbulence, atmospheric turbulence in that area. I think they call it vortex or something. I remember I had a very bad grade in that exam where they asked for this. But it is something that is a very specific location where a certain mixing of the atmosphere happens, and that's why particularly there this reaction of these chemicals with ozone becomes particularly strong. If any one of you knows better and wants to correct me, feel free to do so. Okay, so what's the consequence? The consequence is that the UV light will no longer be filtered out and comes all the way to the ground. And if it hits our skin, if it hits plants, if it hits our eyes, then it can cause damage. And that is why people are concerned about the ozone depletion, because it is quite harmful for humans. Any more questions about that? Otherwise, I move on. Global warming, I think most of you know that, so I won't go into detail here. We all know it's about the absorption of long-wave radiation, then these molecules start vibrating, then they may release the heat again, and that's how it kind of accumulates here in this lower part of the atmosphere. So one thing that is important here is the greenhouse gases, they don't break when they do that. So they can do that over many years. They basically just take in the heat, vibrate a bit, and then release it back. And they do that many times. Now, greenhouse gases, or CO2, is also responsible for something that we call ocean acidification. And I have a question here for you guys. What's the difference between ocean acidification and acid rain? Is that the same? Are they related? What causes ocean acidification? Yeah, go ahead.
CO2 dissolves in the ocean water.
Okay, very good. Yeah?
Acid rain means the CO2 just goes to the clouds and then absorbed by clouds water and then just comes down as rainfall.
Okay, very good. So when we have the CO2 released into the atmosphere, if the pressure of the CO2, if there's more CO2 in the atmosphere, what will happen is that the amount of CO2 that is dissolved in the ocean is imbalanced. There's more CO2 on top than in the water, and that's why some of the CO2 will migrate into the ocean, and there it forms an acid, and that's why it contributes to ocean acidification. When we talk about acid rain in the air, oh, I think I wanted to skip these questions. Yeah, okay. When we talk about acid rain in the air, we actually talk also about other chemicals, namely sulfur dioxide and NOx. So these guys here are actually very strong acids, and when we release them into the atmosphere, then they can make the rainwater very acidic. Does anyone have an idea how acidic is 4.2 to 4.4? Is that super acidic? I actually have a interesting experience. When I was a student in the Netherlands, there was a party from the Chemistry Association, and they gave all the students red wine, and you had to drink it and guess what pH it had. It was a really, really bad tasting wine. It was pretty sour, and it was 3.5. So around 4 is actually pretty sour. May not be lemon sour, but pretty sour, and you would be able to taste it. Now, what is the pH of normal rain?
6.
Okay, 7 is neutral, right? Why would it be 6, not 7? Correct. So it's something around 5.6 naturally because of the carbon dioxide. So this is like the normal rain is a little bit like the ocean acidification, just with the CO2. This would be the value. And then the other gases make it even lower. Now, why is this a problem? So what happens if acid rain gets into a lake? It will affect the growth of anything that grows inside the lake. So just imagine, hard to compare. If I would ask you to take a bath in acid, probably your skin would also not be happy, right? So it's something that the living environment for different species would just degrade, and they may not grow anymore or grow slower. Another thing are also plants, that it leaches out nutrients. So it makes nutrients leave the soil much faster, and that's why plants may have a nutrient deficiency if we have a lot of acid rain. Last but not least, this is something that I was very interested in when I was doing my master's. It can actually dissolve certain minerals in the ground. And if it's super, super acidic, it will release aluminum. And aluminum is actually quite toxic. So if it's really, really acidic, this reaction will happen and will release some aluminum ions. And that's why, for example, fish may be dying because they are, the aluminum is intoxicating them to make them die. So acid rain is actually a serious problem, but as long as we are controlling the sources of these two guys here, either by not using the fossil fuels that are releasing them, or by scrubbing them out to take them out of the air that we release, we can address this problem. So in Hong Kong, do we still have acid rain issues? No, not that much anymore. So it's something that we solve. I didn't solve it, but I think other smart people solved it quite a while ago. Okay, then one more time back to ozone and smog. What are these guys here? Why do we have ozone in Bangkok? And is that something that is good or bad? We know super far up in the atmosphere, ozone is pretty good, right? It filters the UV. How about ozone on street level? Does anyone know what it does to our health? Is anyone here who has asthma or who has breathing problems if the air is really bad? Oh, we are all the lucky ones. Okay, so if you have problems with that, then you would be definitely noticing if this is happening. So the tricky part about ozone on the lower ground is that it's not something that we release directly. It's something that reacts in the atmosphere, and it is made from NOx and different kind of other organic chemicals. Now, the thing here is that ozone is actually one of the chemicals that is still a big problem for us. Why? We can actually regulate the release of nitrogen oxide quite well. I will tell you in a moment where it comes from. But these guys here, it's a whole family of different guys. And it's not very easy to control them, especially because some of these guys are coming from human activities, and some of them come from plants. So actually, the environment helps to make this chemical reaction happen to form ozone. Very tricky chemical story, but it is something that in Hong Kong and mainland China is one of the key pollutants that we are still struggling with. Particulate matter, was something that most of you, or many of you, said that you're quite familiar with, so I won't go into more details here. Maybe one disclaimer is that particles can either be directly released, or they can be forming inside the atmosphere. If you release certain gases that have the capability to form aerosols or attach to aerosol particles, then they can contribute to the formation of aerosols. And normally, the composition of these guys is a pretty good chemical mix, so they are not super healthy to inhale. Can be okay, can be tricky. Also for these guys over here that are directly released, most of the time, or sometimes it happens that the particle is actually not that toxic, but they are great surface for anything else to attach. So some of the gases that attach to it may be causing the toxic reaction. So particulate matter is one of the pollutants. When you inhale them, they may or may not cause cancer. And there's actually no threshold. So in general, it's always better to have them very well controlled. Or if you see a bus with a black fume, walk away. Okay, don't go there and take a good breath. Okay, also I actually did once in my classes some measurements where the students were measuring at the bus stations, and they said if you just stand about 1 meter away from the bus, that already makes the air quality much better. I'm not sure whether they did the measurement all correctly, but yeah, that was one of their findings. So if we combine a lot of different kind of reactions, ozone formation, particle formation, other chemical reactions in the atmosphere, that is what people normally call smog. So a pretty nasty mixture of different kind of pollutants. It's not a one specific chemical or one specific process, but rather a combination of different things. Okay, I think with that, we wrap up the air part as well. So air pollution, the important thing to understand is that if the gases are reactive, they normally don't stay in the atmosphere for long, right? That means they don't travel very far. So these guys over here, you can see from that, I said, okay, it's not super clear, but normally these kind of guys here are more local air pollution, urban air pollution aspects. Some particles can travel quite far, but overall it is within a certain radius that they may travel. Now when it comes to these guys here, they are so stable that they can travel all around the world. So that is why when we are talking about ESG, when we are talking about life cycle assessment, people normally always include climate change. Why? Of course, one thing is that it's a big problem globally. Secondly, it doesn't matter whether you release your greenhouse gases here in Hong Kong or in Germany or in somewhere in, I don't know where, Siberia. They will all accumulate into the same pot. Versus some other chemicals, they are more local problems. And that's why when we are talking about emission and emission regulation, for these guys here, it's much easier to take measures. These guys here become a global problem. And you basically need different kind of countries to work together in order to solve the problems. And there it comes back to, is Scope 3 our problem? Scope 3 emissions? Yes, of course they are. Because in the end, the environment doesn't care whether you release it or I release it or somebody in China or somebody in Germany. The environment will just react. So the question of who's responsible for what is really a matter of how serious we are in terms of addressing that. So pushing everybody to do their best possible, I think, would be the best way to really try to minimize what we are releasing into the environment. Okay, so sources of air pollutants. I think, let me quickly check if that is the last part before the break. Yeah, I think we can take the break after this. Okay, So sources of air pollutants. Here are a whole list of nice guys that cause these problems in the environment. Does anyone know what kind of activities, industrial activities, do we need to do in order to release these? Where do they come from? Like what causes the acid rain? Where do these guys, or you can see actually many of them are duplicating, so they are quite similar. Some of these ones here are also similar. Very good. So if we look into these guys here, the majority of them come from burning fossil fuels. And as they are repeating over here, the same is true for them. So I think I have a chart of the Hong Kong emissions. Over here. So this is a graph that is always published. It's the Hong Kong emission inventory that says, like, where do these different guys come from? And if you look into the list over here, what you can see is that, what can you see? What kind of processes are these here? So if we look into planes, shipping, road traffic, electricity generation, combustion, all of these guys here normally use fossil fuels to some extent at least. And that is why they are the typical emission source for all of these over here. So we can see here transportation, manufacturing, all these kind of things come from or are sources for these kind of chemicals. Now a special one here are volatile organic compounds. These guys may come from other chemical processes, or has any one of you ever been to a gas station? Do you like the smell there? If yes, then you're friends with some of these guys here. Okay, so this is one of the ways that if we are extracting oil, then some of the oil will, have components in there that can get into the air and are volatile. Okay, what else do we have? Over here, ozone-depleting substances. Has anyone ever heard of the Montreal Protocol? That was like an international agreement where they said, like, oh, let's stop blowing out some of these guys over here in order to stop the ozone hole from growing. So here we have a number of chemicals. Nitrous oxide is the only thing that naturally occurs in the environment. We already talked about this, mainly from fertilizers or from soil processes, the bacteria. Some of it also comes from chemical manufacturing. Now these four guys here are problems that we all made the problem by ourselves. They are all synthesized chemicals. And initially we thought, wow, they are a great idea. Let's use them. And then later on we found out, oh, they are actually destroying the ozone hole. So what are they used for? Bromofluorocarbons are flame retardants. Have you heard of that before? So if an electric wire in here starts burning, what will this monitor do? Will it burst up in flames? Normally not, because these types of chemicals are added into the plastic so that the plastic will not start burning. If you go for barbecue and you throw the plastic into the barbecue, it will burn quite quickly, right? So we add these kind of chemicals into plastic, especially for electronics, in order to not make it burn quickly and not to be a hazard to people. So in your TV, in your laptop, and all these kind of things. So the older these guys get, the more easily these chemicals can come out. As it, the plastic gets more brittle or it heats up, and then some of these guys can come out. And the others have different kind of uses. Usually was for very typical refrigerants in air conditioning or refrigerators. And tetrachloromethane, actually this is something very interesting. Does any one of you sometimes go to the dry cleaner? Yes. I'm always wondering whether it's still allowed here in Hong Kong. It's something that is banned in many countries because it is really, really toxic also for human to directly use that. So it is a very good chemical cleaning solvent, and like that can also get into the environment. Now, greenhouse gases, methane, I think most people know because the cow is digesting and releasing methane. It can also come from, for example, pipelines. If the gas pipeline is not properly maintained, the leakage may release some of the methane. Why is it actually a problem if there's a leakage? Is there a problem with methane in general? Is it a good greenhouse gas? It's a pretty strong one. It's a lot stronger than CO2. It's not the strongest one, but methane has a much higher capability to cause or to trap heat than CO2. So I'm often wondering if you're using gas in order to generate electricity, in order to reduce the amount of CO2 that comes out compared to coal, but at the same time you have gas leakage of methane, and the methane is actually much stronger, how much it balances off. So the management of these kind of gas resources is really important in order to not have the methane leak into the environment before we can actually burn it. Okay, so briefly about the other ones. I think most of them I already went through, so I skip here. We already saw this one. Okay, for this one here, I just keep it here on the slides. It's like, why is there NOx, why is there SOx, why is there particulate matter coming out from the combustion? So if you're interested, you can go into this. So to wrap up this emissions part, one thing that I find very important is that most people, they know carbon footprint. Have you heard of carbon footprints? Right, pretty common now. Carbon footprint is one of the emissions that we measure for products, most of the time we associate with products or with people's lifestyle. Now, carbon footprint is one aspect of environmental impacts. Other environmental impacts are typically assessed when we do life cycle assessment. So life cycle assessment is not just looking into climate, but also many of these other impacts. Why is that beneficial? Because when you think about it, let's take the example of an electric vehicle. Why do we have electric vehicles? What's the benefit of an electric vehicle?
Expensive.
Oh, it's expensive. Is that a benefit? Yeah, not so many people buy it, right? And then the ownership is low. That's good, yeah?
My vanity. Vanity game. Okay.
Anyone else? Why do we bother to have EVs? Yep, very good. So if you look into the life cycle over here, this stage over here is what we want to improve, right? When we burn the fuel, normally there's CO2 emissions. If we have EV cars, ideally, if we have nuclear or renewable energy, then there would be no more emissions. Now, if we only look at the carbon, what are we missing out? What other environmental impacts may we forget about? Does anyone know about EV cars? Batteries, very good. So if you think about the life cycle, we are fixing this part here. But once we are switching from EV car, from gasoline car to EV car, the entire life cycle would be changed. We need different raw materials or different amount of raw materials. We need a much, much bigger battery and accordingly much more raw materials. The production lines would be changing. How we assemble the whole thing, how we put everything together. The use phase would be changing, but also the end of life, the recycling. And battery recycling is something that I remember 4 years back, there was a car accident in Austria. In Austria, I thought, oh, this is quite advanced. There was a car accident with a Tesla in Austria. And then they came to the site, and then the Tesla was broken. And they couldn't find any car company that is normally taking on broken cars to recycle it. Why? Because it had the battery inside and they had no expertise to deal with it. I bet in Hong Kong, I hope in Hong Kong we do have this expertise. Not sure. But anyway, many countries want to go towards EV cars. But setting up a good recycling system is really, really important to recover some of the materials and to make sure that there's no leakage of toxic chemicals that could be coming out from different kind of operations. So it is something that when we only look into this aspect and only look into carbon, we may actually overlook different other implications that come with this transition for our supply chain, for our recycling, local recycling. So that is something why it makes a lot of sense to look into different kind of environmental impacts. Okay, last but not least, how good or how bad are we doing overall on this whole thing? When we think about emissions, and you would give us a grade from A to, what is the worst, F? A to F. In terms of managing our emissions and keeping the environment at a state where we can say like, good, it's still safe to go. What grade would you give us? E? Anyone who would give a more optimistic or pessimistic one? D, okay. So there's a research team which came up with a system called planetary boundaries. Not sure whether you have heard of that. And they also characterize the environment into the different environmental categories. And they measure what's the status of the environment right now. For example, for carbon, they measure the CO2 concentration in the atmosphere. Or for ozone depletion, they measure the amount of ozone that is still available in the atmosphere in a certain area of the planet. So here's the result. We have 9 different categories. And in 6 of them, we are at a state where people say we can no longer guarantee a safe operation for human in the future. We have been exceeding already most of these kind of categories. So some of them are related to water use. We have certain areas where there's so much water depletion that we have severe problems, especially with agriculture or even residential, that people don't have enough water, industries that they need to move away because there's no longer enough water. Land use change, we have a lot of issues with that. We will go into that in a moment in the resource part and the last part. Biosphere, we have a lot of problems with species dying out at a really, really fast rate. Climate change, no need to mention, we already know. Novel entities is chemicals. Chemicals, synthetic chemicals that we release into the environment without knowing what they're going to do there. Massive amounts. And we don't know how bad the problem is, but we do know that the concentrations that we already release out there and the amount of chemicals that we are producing and using every day is really big, and they get to some extent into the environment without having any idea what is going to happen with them. There have been different kind of occasions where people thought a chemical is a pretty good idea. There were certain pesticides where people found out after a while that they are really toxic. There were different kinds of micro, how are they called? Antibacterial chemicals that we put for decades into our shampoos, lotions. Nowadays, if you go to Watson's or something, you always see like no parabens. If you have ever wondered, that is something that stabilizes the shampoo and has hormonal effects and cancer-promoting effects. So that's why, not all parabens, some of them, and that's why they remove them after decades of using them in the personal care product industry. So we're doing pretty okay in terms of managing the ozone hole. In terms of aerosols, things are on a global level apparently still manageable. And in terms of ozone acidification, we are not too bad yet. We're getting there though, because it's related to climate change. So overall, unfortunately, we are not doing too well. And it is a really important point here to make, is that we can't just look at climate. I understand it's a big issue, and it's something that probably will kill all of us. But there are different other issues, especially when it comes to toxic chemicals, that can cause a lot of problems locally. And most of the time, we produce chemicals, textiles, all leather in countries where there's no proper environmental regulation, no proper occupational health and safety. So it is something that we in Hong Kong should also pay attention to. What kind of suppliers do we have? What kind of chemicals, what kind of regulations do they use in order to not make this problem worse, and in order to not affect or let the community around the plant suffer and we take the benefits from it, right? So environmental justice is a very important point here. So with that, I will take another break. And Karina, did you want to directly announce, or we do it at the end?
Yeah, maybe after the break. Yeah.
Okay, great. So we take a quick break for another 5 minutes or so. So we restart at 11:37. Okay, the last topic that we have is about resource depletion. There are here some typical resources. Now, I don't work a lot on resources normally, but I wanted to pull out a few interesting facts for you. And the first one, I shouldn't have mentioned that I don't eat fish, because now this sounds like criticism. Here's a comparison of what we eat compared to other countries. And I compared it in order to make everybody who is eating meat in Hong Kong feel better, because where I come from, people also eat a lot of meat. So if you look over here in terms of fish, how much fish people are eating in Hong Kong, we are actually some of the leaders, together with South Korea, Japan, here in Asia. Not surprising, right, because we are a coastal city. So accordingly, people in Hong Kong might be more interested in the, the fishing or fish producing industry. One thing I want to point out here. Does any one of you know how many proteins we should take in per day? How many grams of protein?
Depends on your weight. For example, I am 45 kilograms. Suppose I should intake 45 grams of protein per day.
Yeah.
Or around.
Yes. So slightly less or around 1 gram of protein per kilogram of body weight. If everybody would stick to that rule, would mean that everyone in Hong Kong was overweight. We eat about double the amount of protein what people say is a healthy intake of protein. Actually, there are some health consequences to too high protein intake. I remember I once had a student in class, and she said, oh, I mainly eat meat because like that I won't get fat. It's like, yeah, but too much protein is also not very healthy. So balanced diet. Anyway, so I think it is interesting to look into where our protein sources come from. And most people actually don't know that meat is not the major protein source for human. The majority of protein comes from plants. It's just that in Hong Kong, the majority of the protein comes from animals. But in most countries, it looks more similar to what China has over here. Globally, around 2/3 of the protein that we eat are in different types of vegetables or grains. Okay, so much background. But what we can see over here is that fish is a pretty big deal in most countries, and it is a healthy protein source, as many people say. But of course, it could be that the fish is toxic, but this is something that anything can be toxic. Now, if we look into the relevance also in terms of fisheries, we can see that globally, there are a lot of people working in the fish industry, and the majority of them are working in the fish industry in Asia. Okay, so we have a huge fishing industry in our region. Now, why is this important? Because we are doing it too much. And overfishing is unfortunately an issue. If we look at the global picture, and in the next slide you will see why the statistic here doesn't look too alarming. Okay, it looks alarming, but when I saw the figure, I was thinking like, oh, okay, 60% sustainably managed. all right, you know, not too bad. Maybe could at least get a C, maybe, right? Maybe a D, but not a F yet. So if we look into the fish stocks, we can see that a number of the fish in our oceans is not sustainably managed. What does it mean? Does anyone know what does it mean if it's a non-sustainable fish?
It cannot be reproduced itself without any intervention.
Yeah, very good. So it means that we basically just take out so many fish that the fish are no longer meeting each other in order to reproduce. Okay, the population is just too small for them in order to quickly rebuild their stock. So sustainably managed fish stocks, and there are different kind of definitions, but the most common one is that it's okay for us to take out the fish as long as the fish stock is not declining over time. As long as we are not eradicating them over time, it's all right for us to go fishing. Okay, and that's the 60% here. They are managed in a way that we are taking the fish, but we are not overdoing it. And I think that's an important definition here. Now, here we come to the interesting part. 1950s, what's the problem of overfishing? What can you observe from this card? What was the overfishing issue in the 1950s? Or whose issue was it?
Mostly Western Europe, Northern Europe.
Very good. So we see here around the UK looks pretty bad, around the Scandinavian, also here a little bit in North America. Now I show you the next picture, which is around 50 years later. What can we see now? What are some of the patterns that you observe if you think about 1950s and 2005? What are some of the key changes? Any fish lovers here who can relate to this? So I think there are a couple of trends. What is the most obvious trend? Right, Asia has a big problem. That's the major aspect here. If we go all around Southeast Asia, China, around Japan, we have a whole area where we have overfishing issues. Now I go one more time back. Is there any other observation? So people used to do fishing in the coastal areas, right? But now we have really good technology, really efficient technology to take out a lot of fish and do it in the deep sea. So what you can see here is that even the areas that what we call is like deep sea or international waters, they don't belong to anybody. People go there to fish it empty, not just to fish so massively that the fish can no longer replenish. And they are not even theirs. You know, it's not even their own. So this is a very big problem, especially because in many of these countries along here, we have a lot of small-scale farm or fishers as well. So imagine if I'm a big company from Germany and I come to your country and fish right in front of your harbor or right next to where your waters end, and then I fish it empty there. What are the smaller farmers or the smaller fishers going to do? It causes a lot of issues in terms of environmental justice that a lot of the smaller scale ones are no longer having access to these. So overall, what we can see is, or a couple of trends that we can see in terms of overfishing is, Asia is one of the hotspots. Overfishing is a big deal here. It is possible actually to measure the fish stocks. Unfortunately, a lot of data is still missing. I think Japan is measuring quite a lot, and we're doing more measurements in the coastal areas. But there is a lack of understanding of how bad the overfishing situation is in a lot of the Asian waters. Also, we do see that if we have regulations Like in Hong Kong, I think Hong Kong came up with a trawling ban. If we say like certain types of fishing, or fishing during certain seasons, or fishing in certain locations is banned or is restricted, people can only or have a fishing quota. Like that, it's actually possible to restore the fish stock if they have not died out completely. So it is a problem that we can actually address, but it does require governments to work together. Especially here in Asia, we have a lot of these problems happening across borders and in international waters. But it is something that theoretically can be addressed if people do take action. Next, water stress. So before I go into that slide, I would like to ask you, why do you think can it happen that a location has too little water? What might be the reason that we are talking about water risk or water scarcity?
Maybe a lack of fresh water.
Mm-hmm. Very good. So we do have certain areas in the world that just have very little rainfall, right? So if you're in a desert, it's just not very easy to put up a farm there and harvest anything. And we do have certain areas where people took out more water from the lakes, from the rivers, than what the rain could refill. And that's why we call that physical water scarcity if a certain area just doesn't have enough supply. Of course, you could say like, well, human could just adjust, right? So of course, it's a two-way thing. But there are certain areas globally that literally have very little water. Now, when it comes to mainland China, does mainland China generally have water risk?
Depends. In southern China, I think probably not that serious, but northern China, I think it is.
Yes, so in China, I think there are different areas that are affected because of different reasons. So typical reasons for water risk, what we call here economic water scarcity, are one is pollution, that we don't have sufficient or didn't have in the past. I think now there has been a lot of things done, but it was for a long time a problem. I remember the first time when I went to Beijing and I thought like, is this a river? It looks like a sewage. Right? So if we don't manage the pollution, it can be a really, really big problem because it's contaminating the waterways. Another thing might be lack of infrastructure, or some people taking out too much and some people not getting sufficient water. Or infrastructures like irrigation that we have very, wasteful ways of distributing the water on the field. So this kind of economic water scarcity is something that happens for many places in mainland China because we do have agriculture, industry, and residential who all three want to use the water sources. And as the industry is growing, it comes up with different kind of challenges. So poor water management, including pollution, is one of the key things that happen in many developing countries, in many emerging countries. So pollution sources could be agriculture, could be mining, could be industrial waste, could even be domestic wastewater. So the more people we have, also urban areas are very typical that people don't manage the waterways well. People throw away their stuff. They pour milk into the river. I saw something that people did that before. So this is something, a source of why sometimes even though we have enough water, it can be that certain people don't have access to sufficient fresh water because the way of how it is distributed or managed. So is it a problem for Hong Kong?
No, not really.
I don't know how it was in the past. I think probably all countries had the problem that like even Paris was putting their feces in front of the house, right? But nowadays, a lot of it is cleaned up. Do we have enough water in the territory to supply Hong Kong? No. but we are really lucky, right? Because Dongjiang is just around the corner. So I think I once heard a talk, and it might have changed, but I think Hong Kong, in terms of water, if we include the regional supply, we are pretty safe in terms of water supply. Should we still think about water? Yes. And why? Because there's something called virtual water. Has any one of you ever heard of this? So virtual water is the scope 3 of the water. Virtual water is what is included in your laptop, in the glass bottle. Now you may think like, well, there's no water in the laptop. No, but making the laptop, like extracting the minerals from, in the mining uses a lot of water. If you're making, these kinds of assembling it, you may need a lot of water for washing, cleaning, to sanitize everything. So virtual water is basically the water that is embedded virtually, that has been used in order to make your product sometime along the life cycle. So if in Hong Kong, actually, Hong Kong U has been, a professor from Hong Kong U has been working on this website where you can go on there and calculate your virtual water. I forgot to put the link. Oh, no, I put it in here, but incomplete. It's called JC-WISE. And the reason why I bring this up is, even though in Hong Kong we don't have a problem in terms of water, we may import products from places that actually have water scarcity. So this is something that certain industries are more water demanding than others. Like cotton requires a lot of water. Beef, different kind of animal products require a lot of water. So it is something that if you're purchasing goods from a location that has water risk, you're basically contributing to making their life a little bit harder, right? So in terms of suppliers, in terms of working with them on these kind of issues, I think it is a good thing to, to be aware of which locations do have water risk, also for companies, right? If they are, there's this very famous example of Pepsi in India setting up a plant, and then after a few months, they had to shut the whole thing down again because they were using so much water that the whole, residential and agricultural sector didn't have enough water anymore. And then there were so many protests that Pepsi eventually had to close down the plant. I think nowadays there's a lot more awareness on this, but it is something definitely for Hong Kong, even though it's not a problem in our territory. I think there's a reason why there is China Water Risk, who's trying really hard to raise these kind of issues and make people aware of it and take action. Okay, I think this is the second last category, land use changes. So you can see over here, repurposing the landscape through human activities, or removing the natural vegetation and using it for human purposes is what we call land use change. And you can see here there are different reasons why this is happening. And let me go into the next slide. Here you can see what are the major top reasons for deforestation. 80% of the deforestation is because of agriculture. So it's not because we want to build more cities or more industrial plants to produce stuff, but most of the land that we need is in order to grow crops. Either palm oil. Palm oil is something that goes into shampoo, Snickers, all kinds of different products, food products, but also personal care products. Soybeans is another one. That soybeans, when we grow them, a lot of soybeans are grown on land that is not, or that used to be forests. And apologies for meat lovers, the biggest problem is beef, because beef, they do require, first of all, they do require a lot of input, often soybeans as well, or certain agricultural areas. If the ground is not good enough, you may still use it for pasture. So there are different reasons why people cut down the forest in order to grow more food for the cows, or directly grow the cows. All right, so what we can see over here, there are other reasons as well, like paper and wood is one of the reasons, I think. Has any one of you ever seen these sustainable paper brands in Hong Kong, eco labels? that tell you that it's sustainably sourced? Yeah, very good. So I think there's a SFC and a PCFC, something like that. So you sometimes see them on printing papers. Basically what that means is that it's coming from a forest that is managed in a way that it's not, you know, cut down completely and then burned off. And it's managed in a way that it can reproduce and the ecosystem is still intact. And it's also in an area where there's not super valuable forests growing. So we have certain forests in Indonesia, Brazil, that are extremely rich ecosystems. And they also can take up a lot of carbon dioxide from the air. So cutting them down is something that people try to avoid because of all the species that live in there, and also because of the carbon dioxide that we are like that. We no longer have the sink to take up the carbon, and normally during, you know, cutting it, burning it, we release additional carbon in there. So sometimes you can see when you see carbon footprints that part of it comes from land use change, and that's exactly that factor, that they are cutting down trees, removing the sink, burning it, and releasing more carbon. Now, on the next slide, it shows if you would make an ecosystem into intensive cropland, what kind of functions would you be losing? So I want you to have a quick look at this one over here. What's the benefit and what's the loss if we go from here to here? So what we can see here is that if we wanted to, of course, if we wanted to grow crops inside the forest, we would have very little land to do so, right? So that's why the crop production here is low. But all the other functions that forests can fulfill, including habitat for animals, plants. You sometimes see orang-utans sitting on a burnt tree because they, you know, don't have enough time to run away. So we do see that a lot of species die when we are removing these forests. The air quality will get worse because if you have ever been in the country park and walk around, normally inside the forest, the air quality is much better. There's a better, what people call evapotranspiration, where there's some, you know, vapor in the air. Also what we see is the water is no longer held by the roots, so it will be running off or you know, moving away much faster. We see soil degradation, water quality decrease. We see easier spreading of diseases because in this ecosystem we have many different species. In this ecosystem we only have one. So if we have one insect that really likes palm oil or palm oil trees, then this is a paradise, and that's why they can easily spread. Yeah, and other aspects. So one thing I want to highlight here is that if we cut down a forest and then we use it, and then after a few years we say like, okay, now we can plant some trees again. Is that solving the problem? No? Why not?
I think because of the ecology there has been damaged, some of the species maybe just gone away or disappeared.
Exactly. Imagine I would kick all of you out of Hong Kong and completely erase everything here. And in a few years, I say like, okay, guys, you can come back now, continue. Nothing is here, right? Our entire system is gone. Of course, our system is different. Like we have houses, we have a drainage system, we have water supply, we have supermarkets. But just imagine if I would remove all that and then put you into Hong Kong on a bare land and say like, okay, now you go. You can have your society back. You can't, right? Because all the stuff that the system is gone, and you can't rebuild the system by just planting a few trees. Okay, so it needs really different types of species. It needs time to regrow and to build up. And it needs a lot of time for those forests to have like a very complex ecosystem. I think it's much easier in places like Germany. The ecosystem is not like crazy diverse like it is in these forests. Okay, last part resource depletion. Now, I wish I was much more of a technical person and could give a lot more examples here, but only a few. I only picked a few examples here. So when it comes to resources, we actually dig out a lot of things from the ground, or take out a lot of things. We already talked about water and fish. So one resource, and I didn't show it yet, but probably, oh, you can guess it from the, if you can see the source link. There's one resource in this list that I'm personally very concerned about. And it is a resource that is our major fertilizer. Phosphorus is a rock, and unfortunately, it is limited. I remember one of my best friends, she did her PhD on phosphorus flows, and she was always saying, how come nobody's talking about this? We need phosphorus to grow almost any food that we are eating on a daily basis. But we do know that phosphorus is a limited supply mineral, at least in terms of purity, in terms of accessibility. So if we are running out of easily available, clean rock phosphorus, it either becomes a lot more expensive to dig it out, or requires additional cleaning, or we may not have access anymore. And then what? Because conventional farming relies heavily on fertilization. So some people may say, like, oh, how about we just grow it organically? Cannot. It's a mineral. We can't just like iron, you can't grow it, right? It's like a mineral that we can't just produce. But if we have a good management of plants, of animal feces, like for example what organic farms do when they don't use fertilizers, if you have a good mix of these kind of things, you can bring sufficient phosphorus into the ground in order to grow plants. The thing is that it's of course a lot cheaper to just use fertilizer than to take time to build up the system in an organic way. So currently, I think if we just rely on organic farming, it would be very tricky for us to produce enough food, because it is a kind of chicken and egg thing. It's like people often said, oh, we had too many people, that's why we had the Green Revolution. It's also because we had the Green Revolution, we could grow more people. So we are very reliant on this system. And now if we are running out of these resources, and I don't really trust these numbers here, you know, people may find new resources or something. But it is something where people think that within the next 100 of years, if we survive climate change by then, this might be one of the things that we can no longer rely on. Okay, another one are generally metals and rare earths. Does anybody of you know what are typical metals that are inside a EV car? I put it down here. If we remove all the casing, like the steel and aluminum, then the EV car requires 6 times more minerals than a gasoline car. Yeah, very good. Copper is one of them.
Lithium.
Lithium, very good. Why do we need lithium? Do you know that?
The battery.
Yes, very good. So most of the batteries, I think there's research going on, probably even at HKUST, and I don't know it, but as far as I know, most of the batteries rely on a lot of lithium. And I would also not know what else. Cobalt is another one. Nickel is another one. I think some of these ones as well, people are doing research on trying to remove them from batteries to find replacements. But it's not simply, you know, that you can remove it and it still works. So there is a lot of research going on making these kind of cars less resource reliant. But as of now, the predictions are that we will need a lot more of these resources, of these kind of metals, in order to make a transition into a net zero, low carbon future. So I found a quote from a professor from the US, and he was saying, with the clean energy transition, we are exchanging a fossil fuel-based energy system with a metal-based energy system. Because if you think about it, if we have renewable energy, we do need batteries and storage, right? Because the sun is not always shining, the wind is not always blowing. if we have electric vehicles, we need a lot of metals, minerals. And nowadays, we tend to have we have the tendency to make everything tech-based, right? It's like with the new Tesla car, you can't even open the door anymore without automatic stuff. And all of this kind of stuff requires chips and requires different kind of metals. So I'm not an expert, but we rely quite a lot on these kind of minerals. I think, and I'm not 100% sure which of these ones are available, I think China is doing pretty okay in terms of having a lot of resources. The big concern, I think, is in European countries. They have close to nothing of this, but they need it for their energy transition, right? So currently, there's a lot of debate about different kind of minerals. Often, the working conditions for getting these kind of minerals are not good for the workers, or the environmental destruction coming from that is really high. So how can we justify electrifying our societies on the back of, on the expense of other people sacrificing villages, moving out of villages because, for example, for lithium, you need to pump out a lot of water from the ground, and then you let the water evaporate, and like that, the groundwater level is going down further and further, and making in these areas groundwater no longer accessible for the local communities. So it is projected that a lot of these kind of materials will be in much higher demand over the next decades. And that's why it's really important to think about how can we make this transition that, I mean, it's out of question. We have to transition away from fossil fuels. But how can we do that in order to, in a way that it does not create a huge amount of new problems? So here is a chart that shows that when we are using resources, different other environmental impacts will happen. So for example, you can see here for iron. Iron is one of the things that we use a lot. So if we are extracting it, there's a huge amount of energy involved in order to process it. So the energy demand is high, acidification is high, a different kind of other air emissions are high, the land use is high. And if we look into some other materials, concrete is something where we do know it has a very high carbon footprint. Copper is something that is very high in terms of toxicity. So they are not just that we are using the resources, but the extraction of these resources may cause new problems. So that is why when it comes to the discussion about resources, we really need to think about how can we make ourselves less reliant on resources. And there are different, I guess, different strategies, but I quickly wanted to put up this chart over here. At the moment, this is the trend for Hong Kong. We have here something called the material footprint. I show you the line. It is going along here. We also show it on this side here. So it's this line over here. And we can see that, OK, these data only go until 2018. But it's going, it's pretty steep up there. Now, what is the concerning part here is how much GDP do we get per materials? And we can see that actually the money that we get out of this high consumption, material consumption, is not super efficient. So in this case, it is something where we really need to work on making better use of the materials that we bring into Hong Kong. This is based on a life cycle approach where they were calculating the imports for Hong Kong. So if we compare this, it's the same website. If we compare this with other places, here's the material use for Hong Kong. If we compare it with other places around here, we can see that Singapore is lower, South Korea is lower, Germany is lower. I didn't check for Japan. Maybe there are some others who are higher than us. But it seems that we have a pretty inefficient material use, and also, in some of the other factors, we are not as efficient. And I don't even want to say that the others are all efficient. But we do have a huge material influx into Hong Kong. And the question is, how do we use these materials in a more sustainable manner in order to gain more money out of it, but also, what I believe, more well-being. So in terms of the strategies, I won't go into, I think this is a whole new topic, circular economy. Just one thing that I want to point out here. From a life cycle perspective, I told you that all these different stages require inputs and generate emissions, right? So the more life cycle stages you go through, normally the more emissions. That's why when it comes to, and this is nothing new if you know the 5 Rs or 7 Rs that the government is always talking about, using, repairing, sharing is always the best option. Why? Because it is looping basically in this life cycle stage. The more you go backward in terms of adding more transportation, adding more remanufacturing, adding recycling, where you break everything down and making the whole thing from scratch, is a very energy-intensive process. Like if you have a metal and you want to make it into a new metal through recycling, you have to melt the whole thing and make it into something new. So it requires more and more inputs the further we go back. I don't want to say recycling is bad per se, but recycling is not the most sustainable option. The most sustainable option is to maximize the utilization of every bit of resources that we put in. Meaning that whatever we buy, we should really utilize it to the max, rather than, replacing it every few weeks because there's a new model on the market or H&M has a new collection, right? Which is, of course, I know it is tempting, and we are all victim of that. But when we think about the resource availability, what we should actually do is to really carefully think about what are the resources that add the most value to me, and what is it worth investing my money in that I can really fully utilize them, rather than having them hang in my closet without being worn, or having the iPhone being phased out when the new model comes in. So I put a few resources over here that I won't go into detail, but people have been proposing different types of policies. For example, putting a tax on virgin materials, primary materials, to push the industry to do more recycling. But it is a tricky topic. I won't go into this. I'm not an expert, but there are different kind of approaches. But I want to briefly highlight this one over here as a final conclusion. We have to work on different aspects, thinking about how to reduce waste and how to make recyclable stuff is an important one, especially when it comes to metals, so that we don't need to do all the mining again. We really need to keep these metals in our supply chains, in our production, and not let them go to waste and then having to mine it all again from the start. We have to increase the lifespan, have to use the stuff for longer, reduce the amount of resources that go into the stuff that we make in the first place. And last but not least, and I think this one here is important, to really think about whether we do need the stuff in the first place. And there's a lot of discussion about how much do we actually need in order to make people happy, right? In the end, of course, everyone wants to be happy. So the question is, how many resources do we need in order to make the most people in Hong Kong have a good life? And as we are moving forward, I think it is something to think about more carefully in terms of what do I really need to own, what do I really want to use in order to add value to my life. And this one here is the head of the European Union who was giving a keynote speech at one of the conferences that I attended, and he said exactly that. It's like, in the end, if people want to, get from A to B, then we should think about how do we get them there and not think about how do we make them own a car or make them buy a car. Okay, so last slide summary. We've been talking about why should we care about the environment. I think every one of you already came in with the mindset that this is not about the flowers and the trees out there, but it is also about securing the resources and the living conditions for human. We talked about this tricky part here, that even if we have the best technologies, unfortunately, humans are not always using them in a way that it is most efficient And unfortunately, our impacts are currently still going up, even though we are so great at making new technologies that are more efficient. But we are also really great in consuming more and having more people consume, which is fair, right? A lot of people in developing countries, they are really striving to have a better lifestyle. We talked about air pollution, water pollution, and the different, how we would score ourselves, how we are doing. We talked lastly about resource depletion and what we can do about. And I think with that, I would like to thank you all. Perfectly on time. Thank you for coming, and hope to reach out again and see you again. I quickly, so we will send the slides. Yeah.
But maybe we start our quick Q&A section.
Oh, you didn't tell me that there's another Q&A. Okay.
Yeah, but maybe should I check any question on stage? Yeah. Okay, maybe I ask the questions because I always have a query. As we know, the government wants to reduce the use of the plastic, right? Maybe this question is related to the life cycle assessment. Yes.
Oh, I like that question.
Yeah, about the government would like to reduce the use of the plastic, right? Because we got the plastic charging scheme. But I heard from the others that, then because of the charging scheme, most of the people just shift to using the cotton bag. I heard from the other that mentioned the life cycle of the cotton bag is even worse when compared to the plastic one. Then from your point of view, should we use the plastic bag or should we use the cotton bag?
Okay. The short answer is use the cotton bag and use it so long that it's worth it. So the cotton bag or many materials, they have a much higher impact than plastic because plastic can be very lightweight. So even if you have a paper box for your lunch, it often has, or like a straw, it has higher greenhouse gas emission or higher carbon footprint because you need a lot more paper to make that straw and not leak through, right, than you need plastic. So in the end, whenever it is single use, if you can't avoid single use, I still think that plastic is probably the better option from a climate perspective, not from a waste management perspective. But that's another thing. I think Hong Kong is a special place for landfill issues and leaking into the ocean. I think that is a problem. But there was recently a study in the UK where they said burning plastic is not the best option. Even if you can get the electricity back, burning plastic has a certain carbon footprint. And as we are decarbonizing our grids, burning the plastic will emit more carbon than the regular electricity. And then people don't want to do that anymore. So putting it on the landfill is basically letting it sit there and nothing is emitted. So to conclude, I think the best option are reuse systems, but they have to be reused often enough because otherwise they cause more impacts. Like if I buy this bottle and I use it 3 times, and then and I throw it away, it's definitely better to buy 3 single-use bottles. Yeah.
Okay. Any other question? Okay, then thank you, Mike. Thank you for
question?
joining us today. And we have another or last workshop this afternoon at around 2 p.m. upstairs. Feel free to join. And thank you again. See you next time.
Thank you.